My name is Sarah Ritchie. I'm the Managing Director of DevTest, software development company. My role is to talk about testing governance. The one thing I want people to hear today is that you need to zip it, pop it, tune it, test it, tweak it every single day.
Sounds fantastic. And how about yourself?
My name is Bruce McLeod. I'm the Principal Consultant for DevTest. What I'm going to talk about today is I'm going to how we drop down into a project at the SDC and deliver it on time, on budget, with quality.
Before I tell you a little bit about how we do testing in the Solution Development Center, I'm going to grab the clicker and I'm going to take you on a journey of my experience. You're going to walk in my shoes, go back a couple decades to where the birth of Agile testing began. Before I show you that slide, I just want to prepare you for what's ahead, what the technology term scrapped means. So this means a lot of these projects never ever made it into production. The first one, this is the birth of Agile testing and where my experience began. This particular CEO was not in the database market. Borland was out there, Fox Pro was out there, DB4 was out there, but this particular CEO named Bill didn't have a database. 4 years later, $8 million, he still didn't have a database. I was invited as a cocky young test lead to work on Access 1.0, testing it, and this is where the birth of Agile testing began for me, and we brought it to the SDC 6 years ago. So I want you to understand that how we do testing here is directly linked to a multi-million-dollar catastrophe for Bill. I'm sure Bill, it's in his book, read his book. I also want you to understand that they happen in Australia. Microsoft Services brings my company out to review some of these projects and have a look at them, either help get down and do the dirty work and rescue them, or step back and deliver the last rites. This particular project, when I arrived, it was the first time after leaving Microsoft. Not one single line of code was there. The reason Bill had us do, the way we did testing on Access 1.0 was that after a multi-million-dollar catastrophe, he never wanted another status report again. He never wanted another hypothetical status light. Everything's on track. $8 million later, you throw it in the bin. A hypothetical report again. He said to us, you will test it every day. You will build it every day, and I will see the data on the defects every day. To do that, developers had to check the code in every day. So he had us deliver tangible physical software every day for the entire life of the project. And that's where the birth of the Agile testing began. We had physical, tangible data that we could test it, pop it, tweak it, tune it, check it, report on it every single day. And that's what we do in the Solution Development Center. This screen right here, a whole bunch of other projects around Australia, also chose not to test quite as early. These projects, again, suffer from some similar situations, which I'll go through in a minute. I want you to understand the difference between traditional testing and how we do testing here in the Solution Development Center. Mostly about this slide, what I want you to pay attention to is between 2004 and 2008, there isn't anything on this catastrophic multi-million-dollar catastrophe list because my team and I were in the Solution Development Center, and those projects were successful. But I wanted to see the list, first-hand experience, sorry. They're out there, and they don't need to be out there. So what do these projects have in common? There's a lot of things in common. I only have time to tell you two. One is either they have no documentation, they have too much documentation. These projects put this stuff out on Word. You can't backwards engineer if you have a marketing change going on. You can't backwards engineer through all that document right in the middle of an iteration cycle. For Access 1.0, and also often in the Solution Development Center, I'll give you an example, the Commonwealth Games. I'll tell you about that later when we talk about others, but you can't take a document like this and go back and redo all of it right in the middle of iteration. Another thing they have in common is when they get to the 65% of the code has been written mark, 65% of that code base has been delivered, usually the testers haven't even shown up. Now they wanted to test it earlier. They wanted to test it maybe 40% of the code has been written. But you know, they do this ritual, this ceremony called integration, and then that doesn't work. And then they try to get it over to the test environment, and that doesn't work. So it's really about 65% of the way is the first time the test team shows up, and the first time you see physical, tangible results on that software. For you, the customer, I can get this to change, that is the first time the CEO who's invested in this realizes this project is significantly off track. 65% of your budget, and that's a number that I just made up, but it's my experience on all those catastrophes. I wanted a little ground to go there. But 65% of your budget's blown before the CEO even knows it's off track. Now, that red line, let's take it back, because I love to do this. That's what I call backwards engineering through 6 months of development code, fixing an architectural flaw. This is what's been going on these projects that we get called into with Microsoft Services to rescue. So how do we do it in the Solution Development Center? How do we avoid those 65% marks? First thing is the day the project starts, and Bruce, my colleague, will go into more detail on this, we have all these things in place in the Solution Development Center working. We have daily builds, we have requirements, we've got everything set up for the day we show up there. We're on site testing that software on day one. When we get to 65% of the way through your projects, we have tested over 80% of your code base. Not only that, we've raised bugs and fixed bugs on over 80% of your code base. We have reported to you throughout the iteration what's going on. What we have is transparency. You can see everything from day one because we, your testers, we can zip it, pop it, test it, tweak it, tune it, report on it every single day, and it's completely transparent to you. Transparency is such a vague word. So what I want to show you is how we do it in testing. How do we, sorry, I love this graph too. The heartbeat. Metrics, statistics, and testing are the heartbeat of this application. Everybody loves the requirements. Customers love the requirements. Everybody wants to know what's been delivered. Testers love to see what has been tested. That big green path over there, we like to come in the morning and see that that's still green. Developers like to know this code coverage of what we're testing, what percentage of the code coverage have we actually hit, and everybody wants to know where the defects in the report are trending. But if you leave thinking you want to implement metrics, you need to know you use them as a complete set. Never isolate them, never go away and go, look how good our testing is, everything's passing. Who cares? You don't know what you're testing. You need to know what you're testing, what code coverage you have testing, what requirements have been delivered, and the defects. So why does metrics go with your morning cup of coffee in the SDC? Fact-based decision making. If you work in the traditional world, testers and developers have often, I'm not saying everywhere, an adversarial relationship. They're not best friends and buddies. Metrics is about the facts. It's all about the data. I don't have a conflict, I don't have an issue because you cannot argue with physical, tangible software that you're testing. It's a fact. It is quality driven. Every day, every manager gets to step back 5 minutes a day, look at the automatically generated metrics, and realize where they might want to focus for the day. And accountability, again, transparency. Bruce and I joke a lot, there's nowhere to hide in the SDC. We know where all the bugs are, we know where the requirements, we know everything. It's completely transparent. So I don't have time to go through all the metrics. I do want to take you through one graph, and I'm going to take you through it in isolation, which is a really bad taboo, but I do want you to understand that there's a logic behind this. This is the active defect graph. This is called the bell curve. It's been around for 20 years. It's the one we used back on Access 20 years ago. The red line at the top is called the defect threshold. It's a calculated number of active defects that we allow to occur on every one of these Solution Development Center projects. We don't like it to go over that line. The black line is the curve that we want the active number of defects to take throughout the life cycle of the milestone of the iteration and also the project. So here's an example of how you use it. When you're starting on a project, you'll have your active defects starting to come in because we're here testing it. You want to look at it as a guide. It's not the answer, but it gives me information in the morning of what's going on. Either this one over here, the developers either are delivering buggy code or the testers are testing on code that they shouldn't be. What is it? Which one is it? The one over on the left, it's the opposite is true. What's going on? There should be more defects coming out today. What's going on? One of two things. The test cases aren't very good. The testers aren't generating bugs because we want bugs. We like bugs. Or, again, the developers are not generating enough code for us to get in there and look at it. Some problems that we see with the active defect. Every software development company project I've worked on does this. You get to code complete. The developers are all free, and it's all hands on deck. Fix the bugs as fast as you can. I call that a death bounce. That project takes the software at the end of the cycle when you're closest to deployment. They throw it into the blender, turn it up, and then they say, we're going to deploy this in a week. In the Solution Development Center, we look for these signs of the death drop. In the first iteration, if we see this, we work with the developers to understand the value of keeping the bug fix under the threshold throughout the life cycle and slowing down the bug fix as you approach deployment. Another one is the flat line. This is a term I made up. Being on some projects that integration bugs work their way into your solution. You want your active defect count to go up and down. It means people are testing, people are fixing bugs. If it flatlines, one of two things are happening. Nobody's working, or the testers are finding as many as they're fixing. If they're finding as many bugs as you're fixing over 3 days, we might have a regression in here that was introduced 3 days ago. In the traditional world, on those multi-million-dollar catastrophes, you don't get to see that till 6 months later. In the SDC, we see it in 2 to 3 days, and we look for it. So that's the value of metrics. Nowhere to hide. You have transparency. We're happy to help you understand how we use these. Come upstairs with the SDC. I've got them plastered on the wall, and I could talk about them all day. But for now, I'm going to turn over to Bruce, who's going to go into the detail of how we use automated testing.
So in the, what I want to talk about now, Sarah's talked at the high level. I want to talk down into what we do within projects to develop quality software. And so following on from Sarah's point about tangibility, we want to make sure that we have software that is always shippable. So at the end of every day, we want to have our code in a state. All the features may not be there, or there may be some curly bugs that we really want to fix, but we could go live with that software if we really had to. Tom's talked about, and Cornelia talked about the importance of reducing that technical debt. So what we want to try and do is we want to find our bugs as early as we possibly can in the life cycle. The reason for that is to reduce the cost for those bugs. If that bug is found by support in production, the cost is huge. If we can find that bug early on, the cost is significantly reduced. Prasadi talked about the iron triangle, the trade-off of features, cost, and schedule. Project quality is another constraint that needs to be considered. If you're developing, say, an air traffic control system, you're going to want to put a lot more time and focus on quality and features than if you're developing, say, the latest blogging platform. And that's just something you have to consider. And if you've got a high quality code base that can be easily refactored, has lots of unit tests, lots of functional tests, that really enhances your project agility. You can take features, you can take late customer requests, and you can really try and implement those and get them out the door. One of the other really key things we try and focus on from a testing point of view is we want to facilitate feature delivery. Last thing we want to be is a wall, is a blocker that is to stop this code getting out the door. We want the whole team to be able to react and move and add features as fast as possible. So at the SDC, we have a quality pipeline. So this is a number of processes. Some we do every day, some we do once an iteration, and some we do once per release. But they're all geared at improving the quality of our software. The key thing, Cornelia talked about it, is those pre-check-in reviews. They are absolutely critical for keeping that defect cost down. We build and test every day. Emma and Simon are going to talk more about build and the details, but every day we build that software and we run every single automated test on it without question. To facilitate that, we make extensive use of test automation. I'm going to cover that in detail in a minute. And we complement that with manual testing. No matter how good your automated testing is, the best thing at finding bugs is seasoned people like me that are angry and old, that looking at Cornelia's code and trying to find those bugs in evil, evil ways. And we do stabilization phases to focus on bug resolution. You have to stop. If you keep adding features, as Rob loves to say, the jelly never stops wobbling. You have to stop and get those bugs out and get the bug count down. So you've heard automation. Tom mentioned it. Cornelia mentioned it. Why do we focus on automation in the SDC? Well, there's a number of reasons. There's the obvious one of catching regressions. You've got an existing feature, new code goes in, you want to make sure that existing feature hasn't been broken. It improves your team agility. The fact that if you've got a late refactoring that you want to do in the last iteration because you come up with a better way to do something, Cornelia, you can do that. If you've got a feature that you need to really get in because you might have a competitor and they've come up with this great new feature and you need that too, yeah, you can throw it in because we design our tool set and our testing to support that. You can make those late-breaking changes with confidence and know that, no, we're not just going to destroy things. And it also increases our testing bandwidth. I love automation as a test manager because it means I can do with a small, dynamic team what might take a team of 3 or 4 times the size otherwise, and you just never get budget for that. So how do we do it at the SDC? We develop it in Visual Studio using .NET. Our people have the exact same skill set as developers from a coding point of view. Makes for great lunchtime conversations, but we have a very different focus. They're trying to build it, we're trying to break it. If necessary at the SDC, we've done this a couple of times. If the commercial tools can't do what we need, we'll roll our own. A perfect example is on the ICMS project, we developed some in-house tools for developing testing InfoPath forms. So for each project, we develop a custom automation framework in the, if you like, the business language of that, the business domain of that particular project. So for a trading system, it might be talking about futures and options. If you're talking about a manufacturing system, it might be talking about products and packages and things like that. The design goals of our stacks, the code must be absolutely durable. So it needs to be able to run and get the same result time and time again. It must be highly maintainable, so we can easily make change, and it must execute very, very quickly. You've heard the number. We have most of our projects end up with about 1,000 tests at the SDC. So we need to have those run every day. We make extensive use of virtualization, both on the client side and also on the server side. One of the great things about the SDC is we have multiple test environments. We deploy to a different one every day. We have no downtime. Absolutely none through environments, unless there's some major power outage, which has been known to happen. From a test management point, especially in Bondi, from a test management point of view, we like to link everything. We use Team Foundation Server for this, but we like to make sure that our bugs are linked to our requirements, which link to our test cases. So there's full traceability. If there's a bug, we can see this was related to these requirements, so we need to regression test these related things. And we also know, okay, here are the test cases that we need to rerun. Rob talked about transparency, and from a test point of view, we love to be transparent as well. So our test results are published every day to the whole team and any key stakeholders that are outside the team. So this is just a brief example. You can see behind me of an email that we might send out. You can see our green boxes for our pipeline across the top, and a brief blurb of, hey, everything's going well, we're ready to ship, or it might be, hey, well, Cornelia checked in again, and we just can't do anything. He's great, he really is. One of the other key things that we do from a quality point of view is the bug triage. So we do this meeting every day when we look at the new defects that have come into the system. So this might be with the test, definitely, a dev representative, an architect, and the customer representative. We confirm the business priority, and we decide an action for every new bug every single day. If we're at the start of a project, we might be fixing everything. If we're at the end of the project, we'll be asking hard questions like, are we prepared to stop this project from going live to fix that bug? So that's a really critical meeting, and it happens every day. So that's pretty much, I'm getting to the end of my presentation, I'm running out of time. So hopefully you can take a couple of those points with you. When you do an SDC engagement, similarly, you get to take your testing assets with you. It's an investment that you make along with the application, so you can take that back to your own team of developers and testers, and you can run that automation. You can help facilitate that delivery. You can still, try and make sure that application stays in the way that it was. So, in summary, to cover my presentation and Sarah's, you want your testing and metrics to be fact-based. Testing is required for success. It's just not optional, in our opinion. It facilitates feature delivery. It's not a blocker. You want to focus on quality from day one. It's not an afterthought, and you want to have some tangible software that you can see every single day. Thank you.